The uniform arithmetic gradient. Suppose we have a cash flow that looks like this. At the end of the first period, we have a cash flow equals to this value. And this cash flow increases by a constant amount at every succeeding years or every succeeding period. At the end of the second period, our cash flow has increased a certain amount, in this case represented by the yellow arrow. And on the end of the third period, the cash flow increases by the same amount, this one, the yellow arrow. On the fourth, and so on. Observe that this cash flow is actually consists of two types of cash flow. The first one is the familiar annuity cash flow. And the second one is the not familiar cash flow, consists of these yellow arrows. So if we wish to calculate the present worth of all of this cash flow, it is obvious that we need to calculate the present worth of the annuity and the present worth of this other type of cash flow. Suppose our first cash flow is A, which is to represent our annuity. So all our red arrows here is equivalent to A. And suppose that the increase in the cash flow, which is a constant number, is G for gradient. So we can now calculate the present worth of all of this cash flow. First, calculate the present worth of the annuity, which is equal to this formula. Next, considering that every arrow here is equal to an amount of G for gradient, calculating the present worth of all of this yellow arrow will yield this formula. So to calculate the present worth of all of this cash flow for the uniform arithmetic gradient, first we need to calculate the present worth of the annuity and the present worth of the gradients and add them together, then we get the present worth of the uniform arithmetic gradient. The formula are a bit complicated, but we can simplify that here. Observe that our first cash flow is A. Our next cash flow should increase by a certain amount, which is in this case is G. So at the end of the second year, our cash flow is A plus a G. Observe that we added only G at the end of the second period. At the first period, our cash flow is simply A. In the third period, our cash flow is equal to A plus 2Gs. And the fourth period, our cash flow is equal to A, and now we have already 3G. Now we can deduce that at the end of the fifth period, the cash flow should be A plus 4Gs. In general, here we have the cash flow located at the end of the X period. Here we can say that the cash flow in this period should be A plus some number of G, and that will be A plus some number of G. If it is located on the end of the 100th period, so the number of G will be equal to 100 minus 1, which is 99. But in this case, in general, we say that the number of G added to A is equal to X minus 1. So, if we want to calculate the present worth of these cash flows, here, let us consider first this cash flow and calculate its present worth. This cash flow is equivalent to some future amount, F. So if you want to calculate the present worth of this cash flow, this cash flow, which is equal to this numerator, divided by 1 plus I raised to the power of x. Recall the formula relating the present worth and the future worth amount is equal to this one. So considering that a plus g times x minus 1 as your future worth, we divide this by this expression 1 plus I raised to the power of n, where your n is the number of periods from year 0, which is in this case is equal to x. So if we wish to determine the present worth of all of these cash flows, not only the cash flow on the x period, so we need to perform the operation by calculating the present worth of each of these cash flow. It is easy to calculate using the calculator function using the summation function of your calculator. So simply input that in your calculator and perform the operation for your x starting from 1 up to n. Okay, let us consider this problem. Find the present worth of all cash disbursements using gradient interest formula. If money is worth 15% per annum, annual cash disbursements increases by 1,000 every year thereafter until the end of the 4th year. The first cash disbursement amounts to 5,000 pesos. Okay, recall our formula. For any cash flow at the end of any period, we have this formula in the numerator. To calculate its present worth, we divide it by this factor, and then we calculate the summation of that to calculate the present worth of all of these cash flows. Now, here is our value. Our first cash flow, the first cash disbursement, amounts to 5,000, and this increases by 1,000 every year. So we'll have 5,000 plus 1,000 times x minus 1. Divided by 1 plus our I is the worth of money is 15% per annum. Raised to the power of x, where your x is to be varied from 1 to 4. Okay,